Good afternoon. Welcome to today's IOER Forum with Horacio Samaniego. And my name is Diego Rybski. I'm going to moderate this presentation. And so I'm going to start right into introducing the speaker. So Horacio is from Valdivia in Chile, and he did his undergrad in biology in Universidad Católica in Santiago. He did his PhD in biology as well, or more precisely in landscape ecology at University of New Mexico with Bruce Milner and Jim Brown. So please correct me later if I'm wrong. And then he did a postdoc in computer science, also at University of New Mexico, a postdoc in Los Alamos in the Center for Nonlinear Studies together with Luis Betancourt. And now he's at Universidad Austral de Chile in Valdivia, in the Forestry and Natural Resources Department. So he has broad interests around biogeography, theoretical ecology, and he studies cities since his postdoc in Los Alamos. And for example, there's one paper, Allometric Scaling of Urban Road Networks, 2008. So this was just after the kind of pioneering paper by Luis Betancourt. But he has also other papers like economic diversification and productivity in cities. And I would also like to thank the Institute for making this possible. So in particular, also the funding, and thank Horacio for coming. So this is really a good opportunity to collaborate. And with this, I hand over to Horacio, please.
Thank you so much, Diego. So thank you all for being here. I'm Horacio. I come from Chile, and I actually I thank the Institute for the fellowship that have allowed me to spend here some time to work with Diego. We're trying to set up some research, some new research, and visiting like different questions and things of that sort. What I brought here to show you is just an ongoing work, I would say. It's an ongoing work that we're trying to get published, and it's just part of this broad research. I don't have a very set of questions that I work on. I'm actually, as a good complexity scientist, I guess, interested in more of the question than the subject itself. So this is one a small work that we're trying to work with some master students back in Chile, and we were interested lately. Two of my latest research projects have been about segregation, trying to understand what the effect of segregation is in the structure of the city and the dynamics of the city, and how this happens across cities of different sizes. I'm not going to show you or dig too deep into that, but I'll be talking about how segregation and access to public green spaces occur in Chile, and I will have to warn you that the infrastructure, the data infrastructure in Chile is we're working on it. We're working on it, and just because of that, I would say that the data here is more. I mean, it's subject to deeper scrutiny, I would say, and I would like your input on that. So I'll start with the usual, the city. What the city is a big object, right? It's not really it's not only a place, but it's a set of networks where people interact, right? And city has good things and has bad things, right? So as cities get bigger, we get a lot of bad things, and one of those is segregation. The other important aspect is the access to green spaces. So we know now that green spaces, green areas are good for health, or we could think of the other way around. When we don't have access to green spaces, a lot of other illnesses, diseases, and bad thing happens. So it's been pretty well established that that mortality increases with the lack of access to green spaces, and that green spaces provide a whole array of benefits. So much so that in green infrastructure, it's been stated as a single and vital strategy that can contribute to the achievement of the SDGs, right? The Sustainable Development Goals that the United Nations has set up. So here are like three of very well-cited works that points towards evidence that shows how green places are important. What we should hope and expect is that everybody has access in the same way or with the same opportunity to these green spaces. So that's what we're going to be looking at. And particularly, we're going to focus on how infrastructure and how the contexts of the locations of these green spaces allow the access, the attractiveness, we're going to call it, to these places on one end. And on the other hand, we're going to ask ourselves how citizens, people from different avenues of life or different socioeconomic contexts actually have access to these green places. So the main objective of this research, of this I would say initial research, is to describe the spatial distribution patterns of green urban spaces in Chile. Specifically, we want to describe segregation in urban areas. We're going to start asking ourselves how green these urban spaces are. How many green areas are they across a latitudinal gradient across whole Chile? Who benefits from its distribution, and how attractive are they to different social economic contexts? The interesting from our ends, the interesting part here is that we've been trying to merge or to bring together three big sets or three important sets of data sets. One is a mobile phone data set. So we have ping data set, so call register, call detailed registers, CDRs. And we have the counterpart actually of the CDRs, which is the extended detailed records. I'm going to show you. Remote sensing information, so just standard NDVI analysis, and the socioeconomic and census data. So we bring all these together to try and look at how well distributed and how well distributed green areas are among these different social contexts. So why we do that? Well, we expect that these will provide interesting and important tools to generate better social policies to build a more just society. That's what the punchline here is. We also want to provide a relative simple way to evaluate social interactions using these alternative technologies. And we want to also make a use case for big data processing beyond these marketing solutions, because we know all these big tech companies are actually using this data, but there's very little being done to really understand how social dynamics occur, right? So the way we approach this, we have in the back of our mind this idea of time geography. This idea of time geography, which is this framework put forward by Torsten Hagerstrand, who proposed already in the 70s that we, using some sort of time registries, we should be able to understand how people use their time and how they wander to different locations across the cities. And he imagined that this time geography framework will explicitly integrate the social interaction potential of places. So even though he was looking at individuals and how they moved, or he was envisioning to look at individuals, how they move across the city, like he was centered on the locations. And because he thought that that doing this aggregate study of space-time, of this prism that he called, it will allow to understand the potential of social interactions across spaces. So I think that this is a very nice and important approach that arises very early on to try to understand. And what I think is a little crazy is that in the 70s, there was no real thinking about that we were going to be here in terms of that we would have a cell phone that will be a real witness of the actual location where you are, right? Even if you lose it. So anyhow, so the data set that we have a data set from Telefónica Chile, which is Movistar in Chile, and these are we have all these red dots are antennas across Chile, and we were given from the company a small sample of 1 month data, which is actually distributed in 4 weeks across 2015, and we explicitly requested for a set of dates where nothing special would occur. So no soccer game, no elections, no big strikes, just a day as a normal business as usual. And what the extended detail record is actually every time your cell phone connects to an antenna, it will leave a ping and a registry in your bill, basically. And with that, we are able to track each cell phone to each antenna across the city, right? And across the day. So we have that for whole Chile, but I will show you, actually, Chile is a small country. So we have in 2015, there were like 17 million people, and in Santiago, 3 million of them. So we end up with a large data set, but not as large as you would think. In terms of segregation or social mixing, which is what we're looking at, we used an index that's developed by the Universidad Católica de Chile, and they call it a Socio-Material Territorial Index, Índice Socio-Material Territorial, which is basically an index that's developed to account for the socioeconomic stratum of each individual, by thinking at individuals not as consumers, which is the way it's been done so far, but more as they call it in Spanish, sorry, sujeto de derecho, so a citizen with his own rights, right? So it looks at 4 aspects. The first one is schooling, then housing materiality, the crowding in the family homes, and the number of families per house, and they develop like a social material index, so it's basically a socioeconomic stratification. And in Chile, it's been described for a long time that, as you will see here in blue, there is what they call the cono. It's a cone of high income. So those are the fancy neighborhoods, the blue ones here, right? And so for each of those locations, and because we know where each cell phone and each individual in the city sleeps, we know because where we identify the location where the individual sits between 7 p.m. and 7 a.m., and we make sure it's a frequently pinged location, we're able to estimate the residences, and we impute to each individual the socioeconomic income that they belong from. Right, and we divide that into quartiles, right? So low income and high income into each 25 percentile. And what we did is that we calculated, and the index that I'm going to use, the segregation index that will be using here is essentially entropy. So we calculate the number, the proportion, how well distributed, what the entropy of each antenna. Here it's aggregated to these hexagons, and we have this little project that we also trying to publish. It's a little visualization project where you can play with entropy, and you can reach the website through that QR there if you want. So as I told you, this is a work that we've been that is being considered for publication. We worked with Diego Calbucheo, which is a master's student in our lab. And what we did is we looked at 6 main cities in Chile, which are marked by letters in the map of Chile. And there are the 6 major regional capital. And what we did was that we extracted NDVI for each city using the Google Earth engine, and we identified the distribution of NDVI for the whole city, and then we looked at how that was distributed for each park, for each urban area. And what we found is that we looked at the social context of these parks, right? And what we see is that even though the data is not that clear, and I would mention that the number of data points that we have for example, Puerto Montt is only 600 parks with a very small population of 300 cell phones only, right? So the signal is not strong. We don't see it, but where we see an interesting tendency is in Santiago, where we actually see that high income, like parks that are located in high income places, they usually have higher NDVI. And the same happens for Antofagasta, because as you might think, if you've traveled to South America, north of Santiago, it's actually a big, very dry desert, right? So Antofagasta sits in the most arid place in the world. Actually, it rains 1 millimeter every 10 years or something. And up to Santiago, which is letter D there, it's very strongly geared, modulated by the aridity. So you also see a larger NDVI for richer place. But I would try to focus here where you see this clear tendency, which of higher income, of places located in higher income places. So then we ask ourselves, okay, but what happens with the income of the people that visits those parks, right? So what we were able to do was also extract the average income quartile of the individuals that go near an antenna, or that register to an antenna that's located in or near the park, or near each of those parks. And what we see here, and so we devised these Sankey diagrams. And for Santiago, what we usually see is that places that have high NDVI, so darker green are high NDVI, usually are associated to socio-material level, so income, to high income level. So that's certainly true for Antofagasta, which is the very high dry place I told you. But it's also true for Santiago, where most of the greener places, they're distributed across the higher income locations, right? In terms of social mixing, what we see is that high income will see also a higher entropy. So that places that are in a rich socioeconomic context usually are more integrated, which is counterintuitive, right? So places that have a low entropy are usually confined to locations that have poor, so to say, socioeconomic context. Now, why would that be like that? I mean, is there something about the parks, something about the? I was talking about how amenities could be important in deciding if I'm going to visit or not a particular green area. And so by looking at that data sets, what we came across was this indicator of the park urban plazas, how do you say, urban squares and parks in Chile. And what we came up with was this very fancy and new project where they're trying to really get all the all the amenities and facilities that are available for each park. And so we went and looked at that. We also looked at how attractivity as a concept that's geared to understanding what the opportunity of access to a given place occur if you use one or another mean of transportation. So we looked at attractivity using pedestrian transportation, so just by walking, public transportation, so it's taking the bus, or by private means, so usually it's taking the car. We didn't have any data set to actually look at bikes or other means of transportation, but basically we mapped the attractivity using the R5R software to identify how attractive all these parks in Santiago were for these. And what we come up with is that they actually, statistically, they don't seem to be very different from another for the different socioeconomic context, but for the highest socioeconomic context in private transportation, there you can actually see a difference. So when you run all this through a multiple regression, right, what you see is that there are three of these, so maintenance, vegetation, universal access, safety, are these variables extracted from these official amenity databases. What we find is that diversity of facilities and private transport, and as well as socioeconomic context, become very, very important for this to identify, to understand how social mixing actually occur. So, as a conclusion, what we find a very counterintuitive paradox, I call it, to give it a fancy name. But what we actually are able to document is that for affluent urban green areas, in general, green parks in affluent areas show less segregation. So there is a more diverse use, there's higher entropy, and what happens is that they actually attract a broader population due to the quality and the centrality of these locations. And on the other hand, less rich urban green areas, so vulnerable parks, or parks in lower income areas, however, they exhibit higher segregation and lower entropy even when their quality is high. So there is a big investment in green areas outside of the affluent context, social context, but in spite of that, they don't promote integration, social integration. So yeah, and the other aspect is that connectivity, not just quality, seems to be important. So even though like multimodal attractiveness or connectivity, places that are centrally located with a high access to public transport, even though they are relevant for the usage, it was the private transport attractivity that was most associated or better associated to social mixing, so to entropy. So park quality attributes influence the ability of urban communities to share common place, but this is very obvious in rich areas where park quality seems to have a more pronounced positive effect on social mixing. And as I told you, this work was mostly done with Diego and Marcello, which just got their master degree in our lab, and I'm very thankful to them. So I would be very, very, very happy to discuss and have a good conversation around this preliminary research. Thank you.
Okay. Thank you for your presentation. It was very nice.